everyone. Welcome to the 100th Melbourne AWS user group meetup. It was 9 years ago or 11 years ago. I really should have double checked my history before we started this broadcast tonight, but it's been a very long time either way. So 100 meetups. We started, pretty sure it was 2011, with 6 people. We don't meet up in person at the moment, but we did peak at around 120 to 150 attendees at some of our special events at the AWS office. More recently, it was probably around the 80 people mark, but obviously we've been running online now for almost 12 months. And unfortunately, it looks like we're set to continue to be online for at least the medium term of this year. As soon as we can safely return to in-person events, we're very keen to get back and see everybody in person again, but only once we can do that safely will that be considered. All right, so we do have a full event for tonight. Happy 2021 for the record, or 2020 part 2, depending on your take of how things are going. So let's jump straight in. Got my slides. So the introductions, this side, is what I'm going through now. Right after me, we'll have a quick news segment from Ian and friends. And we'll also have 2 presentations tonight. The first one from Deb is Cloud Gaming on AWS. This looks like a really fantastic talk. He's got a bunch of follow-up material as well. And then our second presentation tonight is old friend of the user group, Guy Morton, deploying a serverless .next.js app with SSR support. He's pre-recorded this one for us, but he is here to answer any questions we might have. And again, this one looks also really good. So the format for tonight, if this is your first of our online events, welcome if it is. Obviously, this is being broadcast to YouTube and will be available on YouTube for recordings. If you're happening to watch this on replay and you do have any questions, please feel free to join the Slack channels. Details will come up in a moment, and ask any questions you might have on Slack. But if you're watching along live, I hope you have fun tonight. If you do have any questions of our presenters, please feel free to post them in the Melbourne channel on Slack, on Twitter using the AWS Melb hashtag, or right there in the chat on YouTube. At the end of the presentation, myself or Ian will jump on the broadcast with the presenter, and we'll ask all of the questions on your behalf. Of course, we also welcome comments at any time using the same channels. Comments or feedback on how things are going, or just general chat, really. But of course, same as 2020, we wouldn't be able to put these events on without the support of our sponsors. So again, for 2021, we'd like to welcome Enabler as our gold sponsor, and then AC3, CMD, and Do It International as our silver sponsors. A big thanks to all of our sponsors for their continued support this year. Hopefully it's going to be another long and full year of presentations. And yeah, we look forward to their support once we can get back into in-person events as well. So who are we? Very quickly, my name is Rob. You'll see my co-host Ian very shortly in the news segment. We don't work for AWS. We work in the AWS ecosystem. So we're community members the same as you. This user group has a long and proud history of being by community members for community members. And the good side of that is that we welcome all opinions of AWS, the good, the bad, and the ugly. Anything you might want to share with the community that would help make their jobs easier or might find interesting, we welcome all opinions and all feedback. Now, Slack. Slack is the best place to keep in touch with your fellow community members. There are, I think, almost 600 people on the Slack team now, and there's a fair few of whom are online during business hours normally. It's a great place to ask questions if you need any help, or if you find any of the spiky edge cases on AWS. We also have a jobs channel where some of our partners and consultancies in Melbourne will post job vacancies if you're looking for work or if you're looking to hire. We have some of our automated channels as well. So there's a AWS outages bot, and there's an announcements bot that fosters discussions of both. Especially when there's an outage in AP Southeast 2, you'll find the outages channel to be quite busy. The link is on the screen, obviously. But that's not the only way to get involved. We are always looking for speakers. That's the hardest part of putting together a user group, is finding people to present. Doubly so in lockdown. A lot of user groups either went into hiatus or some sort of hibernation last year. We're one of the very few groups that managed to push through, and we've had presentations every month, and we are immensely grateful to our people who've presented last year, and hopefully everybody else who wants to get involved this year. Now, it doesn't have to be some gigantic long presentation with beautifully crafted slides or anything like that. Any sort of opinion or news or tools that you've found. Maybe you discovered a new tool and you thought it was really fascinating and think people in the community might be interested. Even if they're not interested, we still love learning about the different edge cases that people find, the different tools that people find. So it can be as small or as long as you want your presentation to be. We're also always looking for general volunteers. There's a lot of things that go on in the back of behind the curtains. So there's a volunteers channel on Slack if you want to get involved that way. That's all of the slides that I have tonight. Normally I have a what else is happening in AWS space right now, but it looks like there is not really a lot going on elsewhere at the moment. Most other user groups haven't posted details of their upcoming events for 2021 yet. So with that said, let's throw over to Ian and JM for what's happened since reInvent.
Cool. Thanks, Rob. Hello, everyone. And yeah, as Rob said, we're talking about what's new since basically our last meetup, which was halfway through reInvent, because, well, technically speaking, I don't think it was even halfway through, considering it continued into January. So we've got some things from there and then things that came outside of reInvent. So as usual, let's start with what's new finally in Sydney. There's a couple really good ones here. We finally have the new T4G instances. That means these are the new ARM-based, so Graviton 2-based instances. The AWS has also extended the period in which I believe a micro version of this can be used for free for a month. So say play around with it. And the other one that I know JM is very excited about as well is the network firewall.
Yes, of course, network firewall. Everybody has been waiting for it for a long time in AWS, and now it is in Sydney. Not very much time after it came in other regions, so it was just announced before reInvent. So very excited. Network firewall. Finally, you can filter your egress filtering traffic. You can use Suricata compatible rules, and you have IPS, you have logging. So some people say it's a bit expensive. It's around 40 cents per hour per firewall. So you kind of need 3 of them. So when you multiply that by AAZ, that's $15,000 Australian dollars plus traffic. But I did some comparison with all the vendors firewall who are much more expensive. I won't name. They start with a P, but it's around $44,000 a year per environment, even if you share it into shared services. So 3 instances, you need to pay the compute on top, you need to pay the licensing on top. So yes, the network firewall is expensive. It's for enterprise. It's around $15,000 a year, but you end up with something really good to do egress filtering and ingress filtering if you want to. But AWS has already WAF and other type of product like that too for ingress.
Yep, really cool. So the other things that we got here, we can now use Particle for Dynamo. This is something that was announced at reInvent as well, just that you can use sort of SQL queries to attack your Dynamo DB. So
yes, you need the Java runtime for that installed on your machine, but you can hit all sorts of different database. AWS open source that product. They were using that internally, so they open source it, and everybody can benefit from that product now. SQL language.
And if you use recognition in Sydney, you can now use custom labels as well, which is useful.
So I just recommend custom label. It's an AutoML product, right? And you can find object and scene in images, so you can detect face, compare faces, get celebrity info and stuff like that. So it's quite cool. But we're quite limited in the Sydney region. We are limited to 2 operations per second, where other regions are 50 operations per second. So not the full-blown product yet, but it's a good start that we have that product in Sydney and Australia.
Yeah, it's a shame it's not the full version, but cool. On the serverless side, it's not a lot of major things, I think.
Compute optimizer for Lambda, I think that can be quite useful for customers who, try to guess how much memory and CPU they're going to allocate to Lambda. A bit too much, and it costs you more. Not enough, your Lambda will fail. So that's an interesting product that has been added to Lambda. One catch, though, you need at least 50 time to invoke your Lambda in the last 14 days to start having some data to be able to analyze. A bit same at EC2, you need to have at least 30 hours of running time to be able to have some valid data in there.
Yeah, but that makes sense. Otherwise, it's hard to actually see what it means.
Yeah.
The other one, HTTP API gateway, now supports data mapping as well. So it's catching up a bit more to the REST API. And for Lambda, you can now use a self-managed Kafka as event source, so you're not just limited to the MSK version.
So yes, now it's open to other type of Kafka version, as long as you can access them through a public IP or through a VPC endpoint. So Kafka is a streaming service, right? So Lambda is not really. So you're going to batch 10,000 records at a time and then process them in batch. So depending of the size of your payload, and it will accept it to 6 meg payload as well. So obviously Lambda will scale, but you won't have instant response to your events. It will be batched.
Then on the container side, a couple new services. Managed Prometheus. For those of you not familiar with Prometheus, it's basically a way to collect data from microservices. So it's a monitoring tool and very much used, especially in Kubernetes environments. So it's good that there's a managed version of that, and same for Grafana, which is just for dashboard displays or graphs and other things. Both of these are still in preview, so that's a bit of a shame.
But the preview include EKS and ECS as well. So you really, people who use it the most will enjoy that product. And it's another open source product. We get kind of managed services by AWS. So we can talk about that a bit later, maybe.
Yeah. Another interesting release was EC2 Image Builder. Now being able to build containers. I haven't tried this out. I don't know what the difference is. I know I've got issues with using image builder for AMIs. I don't know how well this will work, but if any of you wants to try it out and tell me, you know where to find me.
Yeah. So it automatically distribute the image into your ECR, but I don't know if you go across account or I haven't tested that product yet. Yeah.
On the dev and ops side, one that I'm quite happy about is the Go SDK version 2. I actually wrote a blog post about this being in beta 2 years ago. So it took a while and I almost gave up on it, to be honest. But I'm really glad it's here now because it's a lot nicer. Because if you use JavaScript that now also has a version 3 GA, I don't know how much better that is because I try to avoid JavaScript.
Yes, so improvement for both of these SDKs, CPU improvement and memory utilization for the SDK for Go, which is good. And then for JavaScript, a couple of improvement for the S3 multi-part upload, managing object in DynamoDB and WebSocket as well. So yeah, a couple of good improvement on these two SDKs.
Yeah. Also, we've got some extra new managers in Systems Manager.
Yes.
Because
another
we
list.
want to keep that. Yeah.
So like
change
AWS
manager. Yes, you know.
AWS is venturing in the ITL system now about Change Manager and be able to monitor what change happening in your infrastructure. So it's kind of linked with System Manager. Obviously, if you want to run a run command or something, you can have all the manager approval process, the recording and all of that, and then they charge you 30 cents for each request. So it's interesting that they venture into a space where there is a lot of SaaS vendors already. Try to integrate everything in System Manager.
Let's have a look at security. DNSSEC support in Route 53. If you want to use DNSSEC, this is great news. If you don't care about it, then you can ignore it. Basically, it's built in. It's more or less free, except for the use of a custom KMS key. And it seems to be work fairly straightforward. You just add the records you need and it all goes as you would expect.
So yes, you need your ISP to do the DNSSEC as well, or obviously move your domain name into a Route 53 domain, and use cryptography to sign each record of that hosted zone with the KMS key. So basically, it's guarantee that your DNS record hasn't been tampered on the way back to you or in transit. So it's for very highly secure applications and probably banking applications and stuff like that. You don't want people to intercept your DNS and reroute them to another server.
Yeah. One that's another release here that I care about is the SSO support for AD group sync. So if your AWS SSO uses Active Directory as a backend, it can now sync groups as well, but it will only sync. So you can see those groups in your console, but you can only do that for groups that are actually in use with SSO. So it doesn't touch anything that hasn't been assigned, but only the ones that you have used for granting access to some of your applications. On one hand, that's good from a security perspective. On the other hand, it doesn't solve my issue that I can't actually use CloudFormation for SSO or even the API for SSO with AD groups that have not yet been used, which is an annoyance I've raised many times with the SSO team. But then some other cool stuff.
Yes,
Cloud Shell.
Cloud Shell.
Cool.
Yes, Cloud Shell is pretty cool. It's not available in Sydney yet, but it's a shell environment that AWS provide you based on Amazon Linux too. You can store up to 1 gig of files. You can install stuff. You can do sudo, and by default they give you AWS CLI 2.058 at the moment, and Python 3.7, and a couple of Node.js as well. I think product in there, so you are able to basically run all the AWS command you want into that environment, and yeah, it's pretty cool. It works. For doing training and all of that, get to be very useful for us. You still need to have a Cloud Shell full access policy in effect. So that's an add-on from the IAM policy. So it's not on by default. But automatically, they assume, by the way, your STS caller identity. So when you log in through a console, you can have the CLI. You don't have to enter any keys, permanent keys, or tokens, or anything like that. It's all already logged in for you to your account.
Yeah, it's really nice to have it. And we won't mention that every other major cloud provider may have already had something like that.
From the first day, yeah, but that's okay. That wasn't the critical, and I guess it could be seen as a security risk for certain accounts and certain customers. So treat carefully because it's very powerful.
Yeah. We don't have much time left, I believe. One thing I did want to mention here, because it's interesting, is the whole Elasticsearch situation. So Elastic decided we don't like cloud providers getting money for our product, so they changed their license, which sort of makes it not completely be open source anymore according to certain definitions. Elastic obviously says, yes, it's still open source. Open source bodies, agencies say, no, it's not. So AWS did what was kind of to be expected, and the fork they made in the past for some open source additions, they've turned that into the new open source, completely open source Apache 2 licensed version of Elasticsearch.
So yeah, the next day AWS tweeted that they're going to fork it, and then they forked the version 7.1, 7.10 or 1.0, and they're going to be publishing that code on GitHub in the next few weeks. Some people are very upset with that. Some people are okay with that. There's several forks as well, and I think they were more targeted AWS than Azure or GCP. So some people said, well, Elastic is not that poor little company who don't have any money. So that play was more about, making some more money on top of the product already, which is really open source. AWS sees it a different way. So everybody tried to monetize that product now. But hopefully for the customer, they will continue to use the product the same way and still enjoy.
Yep. Cool. That's a reminder. We'll talk about a lot more of this on the podcast, which we're aiming to record on Friday, and hopefully it will be out next week. And with that, I'll hand it back to Rob.
Thank you very much for listening.
Thank you.
Awesome. Thank you very much, Ian and JM. It's good to see that the wheels are still turning over at AWS and nobody really took any time off after reInvent. So before we dive right into our first presentation, there was one more item of business that I wanted to attend to. So late last year, was it late last year, Ian, I think? Or early this year, Ian welcomed his first child into the world. And so we just wanted to take a moment to say congratulations. and that we appreciate the effort you've put in to still be here, even though you've now got a big distraction in the house. Hope everybody's doing well. But yeah, congratulations. All right, so our first presentation. So our first presentation night is from Deb. He is a cloud evangelist and inspirer. He specializes in cloud infrastructure, cost optimization, application performance. He works closely with a team of brilliant engineers and minds to deliver projects that touch people's lives every day. He supports both AWS and Azure cloud offerings with the pre-dereliction for the early, and is currently leading several projects across infrastructure, across the industries in both public and private sectors. So Deb, if you want to share your screen. All right, you're not live yet. Got to share your screen first. All right, so let's switch over to Deb. Give it one moment.
Thanks, Rob, for that nice introduction. So I'll quickly jump into the topic without further ado. So today I'm going to present a little bit about something which I personally faced the difficulty and challenges. So it's going to be an interesting one about personal cloud gaming rig setup. I'm not sure about how much all of us are into gaming, but neither am I. But I couldn't stop myself from playing Cyberpunk 2077 when it came out. So my dilemma was that I do have a very powerful rig with 32 gigs RAM and 16-core Xeon, but my graphics card is a Quadro 1200, which is for workstation and all, but it's definitely not for gaming. And the other challenge was the consoles are all sold out, and pretty much when I tried to play it on my Xbox One X, which is a previous or last gen console now, it kept on crashing all the time. I think the situation is slightly better now, but it's still a pain. So to be honest, like cloud gaming did take a big shape, and it's rapidly progressing in 2020. Even AWS has jumped on the bandwagon with the launch of Luna. However, unfortunately, in Australia, this side of the world, it's not picked up as rapidly because of the internet and the NBN and all the other stuff. Even with 5G data, it's highly capped, and live streaming does require a lot of bandwidth. All right, so quickly jumping into the solution. So how do we solve this situation that we had? So one thing that I want to bring to the notice to everyone is a G4DN instance. So these are fairly recent instances, and they do have the NVIDIA T4 GPUs, which is pretty much, you can compare it with something that's sort of an RTX 2080. It's slightly less performant than an RTX 2080, but still it gets the job done, and at least it has got ray tracing and NVENC. Now, I'll come into later why we do need this NVENC encoder. It's critical for this project, and previously without this, it was pretty much impossible to play or stream over the cloud. You can go on through the blogs. All right, the other tool that we have is Parsec. So, I mean, there is, I know, tech tapes explaining Parsec, so I'm not going to go deeper into the technologies behind it, but it is essentially a streaming platform which uses a very fancy new protocol called BUD protocol. So better user datagrams, and you can go into dig deeper into the protocol's NAT traversal and how it does all the other stuff. But this protocol sits at the heart of Parsec, and that's how it establishes low latency connection over UDP. Now, this is what our setup is going to look like. So we'll have a user device which is doing which will have the Parsec client installed. And similarly, we have the Amazon EC2 instance, which is a spot instance, because the G4DN instance, unfortunately, is very, very expensive. You're talking about more than $1.60 an hour. So a spot instance gives us a fairly good reduction on the price, up to possibly like 60 cents or even 30 to 40 cents at a good time. Now going into, as I said earlier, NVENC. So earlier it was pretty much impossible to do the encoding because with other devices and all, the encoding times introduces such a huge latency. If you use a traditional VC encoder, it will introduce a 15.6 millisecond latency, which is pretty much more than the latency that you will require for a streaming experience. So with this, the RTX series, or essentially the T4 GPUs, NVIDIA's encoder introduces only 4% performance implication, and it's pretty spot on with maximum to 5 to 6 milliseconds, which I have personally tested, and we'll see soon like how it appears. The other thing is that encoding in H.265. So earlier in last year, the H.265 encoding was introduced along with the latest NVIDIA drivers and also with the Intel drivers. So it's a good thing, and we are at a lucky time to be able to play and use hardware decoding even on the MacBook Pro that I'm using. It's not ideal, but it does get the job pretty well done because it's hardware decoded. And the next thing is AWS automation. So we'll come into this later on, but this is more in the technical side of it. Now I will jump straight away into the project and give us a quick demonstration. So I have open sourced this project. It's on GitHub. Feel free to go through it. It's fairly extensive, and it has got a couple of modules. Each of these Terraform modules. So one is the VPC one, which is the standard one. The cloud gaming instance mainly resides within this module, and you can have a look at the main Terraform file. It's using stuff which are bleeding edge, even in preview, like EC2 launch v2. This is a preview AMI. The other stuff mainly goes on over here. So as you can see in this one, I have automated pretty much everything, including the installation of auto parsec, auto login, graphics driver. You can go through the tutorial. There are other blocks, but all of these are manual over there. But this is something which I believe that if you have to make it into a viable option for people to use, then it should be entirely automated. And all this automation resides within a template, which is obviously user data in AWS, but this is using PowerShell. And all these are PowerShell functions. You can have a play around with it. Feel free to do it. The other thing that I would like to mention is please do use the get S3 object and use an S3 VPC endpoint, because these are fairly big files, and including the drivers and the stuff that we will be downloading off S3. So it's good to have the VPC configured in such a way, which is, again, if you're using this template, you should be able to have that. So this is already pre-configured with the VPC endpoint, and S3 endpoint is already there. So shouldn't have to worry too much. Now quickly, I'll just start by showing what we're gonna have. So we'll have give it some time. Please read carefully. So this is the main Terraform file, which is outside all the modules. So the spot max price, I mean, I've set it to $1, but you can always go into the historic price database and check what's the current price if you want to, but $1 is a fairly good opportunity. You can change the instance types over here. There are a couple of ones which I have shared in the blog. So there are the ones which is the G4DN, DN2X large. My advice will be the G4D and X large, but if your game requires really is able to use multi-threaded, then you can go for the G4D and 2X large. Another thing that we will be showing is the instance storage. So let me bring up the instance quickly. So as the instance is coming up, please do realize that this is important. Please install the tools and all the times first time. So the next time we want to do Terraform apply, you should make this false. Now this is a manual thing, but I am working on it to automate it. Like there's lots of to-dos over here. It's highly automated, but not 100%. The other thing is, if you want to use your custom AMI, if you have some Windows AMIs that you want that is lying around, or you have some baked images or games inside it, feel free to use it. So all you need to do is provide the customized AMI there, and it should bring up. The next way to use the AMI is, once we have the project up and running, there is an AWS automation which will create your AMI, do the rest of the stuff, delete your old image and archive, and put the AMI ID back into your SSM parameter stores. So the next time you deploy, you don't need to worry about anything else. You just click Terraform deploy, and you shut down the instance when you're done playing. That's all. Now going back to the console, we'll quickly check that the instance is running or not. All right, we can see that the instance is up and running. Now, for the first time, we do need to RDP into it. Now, as the script will configure everything, so to get the password, Terraform output instance password. So instance password is encrypted and is stored here. Don't need to worry about security. It's also secured, and I can access the instance only from my IP. So essentially, this setting is already there in the security group. So it will query my own IP and allow me to access. So it is built in such a way to ensure that you only can access your instance and not anyone else. All right, so I'll try to RDP into the instance and see where it goes. It's still initializing. It takes some time. It's doing all the magic in the background. All this user data, it's going to install the drivers, and it also requires the S3 license. So, all right, here we go. So we got the password earlier from here. We're just going to copy that password. Now, unfortunately, the password is not working. One of the drawbacks of live demonstration. Okay, something doesn't seem to be right. This can happen sometimes as AWS keeps on updating their images. Okay, in the meantime, let's go through a couple of other bits, keeping in mind the time. So as I was explaining, the automation is a very simple document. So this is a feature of AWS which we don't use that extensively, but it allows us to do pretty cool things. So there is documentation which are actions and names. So you can have something such as create image. These are AWS provided documents. The other ones are like stop instances, delete image, and the last one is the store AMI ID. So you can exit to traditional direct access into the AWS API, and this is one of those where I'm directly accessing the SSM API as a service. You can do the same thing with S3 and other stuff. So this one should do the entire job. Now to get the Terraform repo running, you obviously need to do Terraform init, which will download the modules and everything. The second one will be Terraform apply. So this will create the backend.terraform file. In this project, I have decided to store the backend into S3, which to get that thing up and running into S3, we still need to do the force copy And the final thing is Terraform output instance password. This will give you the password to do the RDP. Now we are stuck here, so we'll go back and see where we are at. Unfortunately, it's not liking the password and stuff, so I'll give it a last try, and then I'll bring up an image which we are working already on. So this preview image, we have to be a bit careful with this. So this image will keep on changing with time, and that's one of the cruxes of having something which is on preview. So you can always use a traditional Windows Server image, which receives lesser updates, but is more stable. Well, the good thing about having all of this is, as infrastructure as code, as you can see, is how quickly I'm able to spin up the instance and play around with it. That's something which might have taken a long time had we gone any other way. So a couple of things that we will see is that the instance will automatically install the NVIDIA grid driver. It will install something known as Resist Sound, which will come around. The other tools which are in this platform, it can automate the installation of Steam, GOG Galaxy, Uplay, Origin games, and Epic Launcher, if you guys are playing into any of those. And we'll try to see where we are at. Okay, I reckon like there's something going on within the AWS images, so I will just revert back to the default image.
Could you retrieve the password from the console?
No, you can't, because this script actually enables auto logon, so you cannot retrieve the password from the console, unfortunately. So what it does is, so it gets the password as an SSM parameter and overrides the administrator password. Now this is required for this auto login feature. So when you're using Parsec, you don't want to RDP every time, so it automates the login of your instance also. So that's one of the crux of this technology yet. Now this plugin is still in beta, this one. Again, so we are playing with fire over here. So this one, again, the auto admin login, this module, DSCR auto login. This is again another one of those with beta versions. So it's not that reliable. That might be breaking the instance. All right, it's definitely not working. Going to work with this image. So what we're going to do is I'm going to take up a custom AMI, and as I said, like I don't want to install it again. Now the custom AMI was already backed up in this parameter. So what I need to do, what I will be doing, and hopefully we should see this instance go out again. Now, if you go through the README of this repo, you will see there are a couple of stuff that we might need to have on our machine before we actually work on this, which is Terraform, obviously. The other thing is JQ, and it's good if you have a NVIDIA-based local GPU that really gives you the best performance. The last utility is custom resolution utilities. So if you are using a widescreen or monitor or something like that, you should be able to take the benefits of having that custom resolutions. So I have using a Samsung C49, which is an super ultra wide monitor. So it's a 49-inch. So that's why I have this file. So this file is an export from my monitor. Feel free to commit and publish your exports if you want to get those up and running. All right, let's see the last thing. All right, Cloud Canyon instance. As this machine is already set up, I should be able to see this machine come up soon in Parsec. So this is a Parsec client. It looks exactly the same as on the client as well as the host. The only difference is if we go into settings, you will see that I'm using a Mac. So obviously the renderer is Metal, which is better. VSync, good idea to keep it on. Decoder, definitely we should always select hardware. And as I mentioned earlier, the H.265 HEVC, and turning it on gives it much better performance. And on the other side, if you go there will be a host setting, which I will show quickly. So as the computer is still spinning up, I'm just waiting for it to come up. Let's see whether I can audit into this one. Well, it seems there's something wrong with my RDP completely. Okay, that makes sense because it's spun up from the wrong AMI, which is the Windows Server full base. It's definitely what the right AMI, so I will manually override it with the absolute AMI. Let's confirm whether it has picked up the right AMI this time. Alright, that's a good thing. So we'll try to RDP into the instance again. Yay, finally here we are. So essentially, like it could have been because of the user data was taking too long to execute, or it can be because of the image being changed because it's using the EC2 launch, which kind of is updates every day. All right, so it's doing its magic in PowerShell and all. We can just minimize it. We don't really need to worry about it. So this image is pretty much pre-configured. Now I'll go and check the resolution. Let's bump it up to 4K if we can. Okay, this is RDP, so it's pretty much stuck to whatever resolution. But at least now we know that it's working. What we are going to do is check in parsec. Yay, here it is automatically. So this is the experience that it should be. You would not need to RDP into the instance after you install it for the first time. So I'm just going to end my RDP session over here and connect it from parsec. Right. So I'll go quickly. So this is my ultra wide setting at home, which is, as I was talking about, quickly need to reset it. Unfortunately, this is a bug which takes into different monitors. Unfortunately, this monitor is not going to allow me to work. I'll need to restart. But you can get the idea. Pretty much once you get into Parsec, you will be able to, I'll quickly go through the screenshots so you have an idea how to continue from there. So once you're into Parsec, you will need to log in using your Parsec account. Please ignore the razors around. This does nothing. These instances come with an ephemeral storage, so you can always use that. And in Parsec, increase the bitrate to 50 Mbps, and you can do like setup shutdown on idle for 1 hour. EC2 instances are built per hourly. The other one is 20 seconds, and yes, you can overclock it. This is the overclocking script that you can use. So, and also the NVIDIA RDP OpenGL. Now the final one, CRU custom resolution. So this is roughly going to be your cost, 24.7 a month if you're using the standard ones. And as I said, like you can always fine tune your spot prices. The final stage is you can use this automation, which is the image reimage. So this Terraform will already create it. And this is the final goal, how it will look like. I will try to give a last go if it comes back again. It takes a fairly good amount of time. But here is it. You can play whichever game you want. It's a 4K resolution, so you can do whatever. You will get maximum settings, and you can use RTX on once you have all the drivers and everything configured. Now, as a part of the future plan, so as I said, like still the instance price, you still need to manually enter the price. I have set it to $1, but I would like to automate that one. The next thing is at the moment, you'll get a desktop notification when your spot instance is about to be terminated, but ideally it should be coming to a user's device, not into within the game itself. Now, one of the bigger challenges is the games which are fairly big, they still need to be on the EBS snapshot, so that is expensive. So ideally it should be offloaded into S3. Now the Parsec account, you will still need to sign in, but that can be automated also possibly. Now the final stage is build a custom Parsec SDK-based client. As of now, the Parsec client is a proprietary tool, and you will need to register every time you create a instance. So having automation into that will also be helpful. Please, so that's pretty much it. Keep an eye on the project, and it's gonna happen a little bit better hopefully next time. I will still try to log in last time. All right, here we are. Finally, we are at 4K, and let's launch Cyberpunk. And once it loads, we call it a day. So this should be like the end state, what you will be observing. So once you have got all the tools and everything installing, it will look exactly like this. You will have your Parsec client over here. The only settings that you will need to field, as I said, in the host setting, you can make it 50 Mbps, and that's what it is. You can go higher than 60 FPS, but I would say 50 FPS is 60 is pretty much good enough. Here we go, Cyberpunk 2077 launching. You guys able to see my screen over here? Yep, it will come up. It's still blank on my screen. Well, it might not be here, but this is the audio also. Yeah. Can you guys see the screen now? All right. So this is Cyberpunk. I'll just quickly click continue. It takes some time to load up. Yep, that's all right. So we are quitting over here. I'll just disconnect and shut down the instance. It will do the rest automatically. And that's it. Once it shut down, it destroys and creates the AMI, and everything else will be ready to go for you to play the next time. Thanks, guys. Thanks, everyone. And my apologies for the technical difficulties. Yep.
Oh, I'm not in the middle of the screen. Thanks for that, Deb. You've muted yourself, though. You unmute yourself for a sec.
Yep.
Cool. Thank you very
just
much
stopped
for
this,
that.
yeah.
The unfortunately the demo gods were not very pleased with us today.
Yeah.
I guess it's a new year, new time. It's really fascinating to see how that all worked. I had actually had no idea that that was even possible. And you've already architected it to a point where you could almost sell it as a service.
Yes,
Just a few bugs
that's
to
the
work
end
out there.
goal. Yep, that's the end goal, to build it into a platform which is as a service. So essentially, you get your instance straight away. It does the rest of the magic behind the scenes. Now, as I said, like those scripts and those stuff, I'm still developing it as we speak. So it's still a beta stage, but feel free to trial it out. The more we test, the more we can iron out the bugs.
Cool. Are you able to? We don't have time for any user questions at the moment. But are you able
Yep.
to send through the links to your blog for that and everything?
Absolutely.
And we'll post them in the YouTube chat and the if YouTube allows us to, and the and on Slack as well and Twitter as well. Well, thank you very
Absolutely,
much for that.
Thank you.
Okay, so it's time for our second presentation of the evening. Fortunately, Guy has pre-recorded this one, so we're not going to try and tempt fate with a demo two times in a row. That obviously gets a little bit tricky. So, Guy is an old friend of the user group. He appears on the podcast every month, and sometimes in the news segment on this meetup. So if you're not familiar with Guy, he's a principal consultant for Versant, and he likes to get to grips with custom problems and find solutions that work for them. So this talk is based on some work that he did for a customer last year. Let's switch over to Guy now.
Hi folks, I'm going to give you a little talk tonight about using serverless to deploy a Next.js app such that it can still do server-side rendering. So Next.js is one of the many JavaScript frameworks for building websites, and it can be used to have both statically generated pages, but also it can have pages that are set to be rendered on the server side. So obviously you can't just deploy that to S3 because you need something in the back end to actually pick up that page, render it, and present it back to the user. So what we're going to do today is look at a couple of projects that I've built to basically allow that to happen. The first is on screen right now. So I've got a CDK project that builds out all the infrastructure we need. It's going to leverage a project built by some people who are involved in the next project, specifically deploying to AWS in this model. And basically what I'm doing is just putting together all the other bits and pieces that are needed to make that happen. And then I'll just walk you through an example app that I've put together to show you how it works. So on the screen right now, I'm going to open up the project, the CDK project. So I've got this open now. You can see it here. So as usual, you've got your app.py file, which is the thing that sort of runs, everything's going to be run through or called through. And then you've got your different stacks inside it, which you can see here defined, that are being pulled in from here. So here's our actual individual CDK Python defined stacks. So you've got, see, I've got 4 here. I've got 2 secret stacks. So basically the way this works is that it will use CloudFront, and it uses Lambda at Edge to do the server-side rendering. So those resources need to be created in US East 1 because they're global. And then there's some resources that you can create in the Sydney region. So basically I've split it up into those two stacks for individual regions. And so if we just want to walk quickly through those, so they also need to be built in a particular order because they have dependencies on each other. So first of all, let's have a look at the global secret stack. So you can see that this is just creating a single secret, which is going to be in JSON format, and it's going to have 2 keys in it. It's going to have a DNS host name, and it's going to have a certificate manager ARN, and we're going to use those when we create the CloudFront distribution. So that just sets that up, or basically creates an empty secret that we then need to go and populate. I will show you the other secret stack. So the other secret stack is just containing, so this one actually does contain a secret. So the GitHub OAuth token is a legit secret that you don't want people to have access to. So that's creating this. So this stack will be created in the local region instead of the US East 1 region, because these secrets are actually needed by the local stack, which you'll see when we get to that bit. So I've got a GitHub OAuth token secret, which is going to be used by the pipeline to grab the source. So in the source stage, there's a secret which is used by the Next.js deployment. So there's a bucket that it's essentially the bucket that Next.js writes all its output to. And then there's a CloudFront ID. So when we run the second stack, which I'll show you in a sec, in the US East 1 region, we'll end up with a CloudFront distribution ID. And so we're going to store that in here so that, again, that can be used when we build the Next.js local resources, because it needs to know what its CloudFront distribution ID is. And that's it. So that's what those 2 things are for. And then we're just outputting them with convenient names so that we can refer to them in the other stacks. Next, I'll show you the WAF stack. So the WAF stack creates not only the WAF, but it also creates the CloudFront distribution. You can see I've commented out a couple of things here. So the WAF stack's kind of interesting in CDK. Now, it may be that these bugs are fixed in a later version, but there was a couple of things that that when I actually went to implement this for a customer, sort of bugs that we came across. Bugs in CDK, who knew? But anyway, so there was a bug that we had to kind of work around when creating IP sets. So the IP set is just a set of IPs that you can whitelist or blacklist. So I don't need that for this demo, so I've just commented it all out, but it's in there because all this code's on GitHub and I'll point you to it. So if you want to just go and pull it out and have a play with it yourself, you can do that. So essentially we've got a stack here that's going to create the CloudFront distribution and the WAF that the CloudFront distribution is going to use. So you can see up here that it's pulling some secrets. So it's pulling the web infra secret ARN. It's importing that value from the global secret stack. So remember, this stack's running in the US East 1, so the global secret stack outputs are available to it. So it's pulling the ARN to the secrets, and then it's pulling those secrets in. So it's pulling the ARN of the certificate manager certificate, and then it's pulling in the DNS hostname that's going to be used with the CloudFront distribution. So we've got those things. Now we're going to create the WAF stack. So it's just a straightforward, the scope is CloudFront, so that means it's global. Whereas the scope, if the scope were regional, it would be a regional WAF, which you'd use if you're binding it to a load balancer or something similar. So you can see I've got some rules here, including the one that I've just commented out because I don't need it, which is the IP set one. And if you do need to do an IP set, that's an example of how you do it. And then I'm just using the common rules from AWS managed ones. I don't have any particular need of any sort of complex or difficult rules. I've just chucked in the standard ones, but you can create your own rules or decide whichever rules you want. Now you can see here I'm creating a bucket. So this is the bucket that's going to be used for the static resources that Next will generate. And you can see I've created an origin access identity for it as well. So that's going to bind the CloudFront distribution to that bucket and allow it to access all the contents therein. And it also means I can block all public access to that bucket using this handy dandy catch-all up here. Then you can see I'm creating the distribution. Create the CloudFront distribution. You can see I've got the WAF here that I've created, up there in the code. I've associated this WAF WebACL ID to the WAF ARN, and then you can see I've configured some. Sorry about the help stuff popping up. It's trying to be helpful, which is nice. You can see I've got a source configuration. Pointing it to the bucket source, so that's one of our origins. And then you can see here that I've got a certificate binding the certificate to the CloudFront distribution here as well. There's also aliases, so that's where I'm using the DNS hostname that I created and stored in the secret. That's being used there. And yeah, security policy, etc., just standard sort of CloudFront distribution stuff. And then you can see I'm outputting a couple of things here. So I'm outputting specifically the bucket that is going to be used for Next to write its files into, and the distribution ID, because again Next needs to know that. So we will we'll move on to the pipeline. So the pipeline stack, basically what it's doing is it's configured here with the repo name, branch, and repo owner of the public repo, which I'm going to show you, which I'm going to share. It also is importing the secret that we created in the secret stack, the local secret stack. So that gets us the GitHub token that will allow Code Pipeline to create a source stage that it can access the code out of GitHub. You can see I'm creating a state bucket here. It's a bucket that is used for when we do the deployment. Next.js creates a .serverless folder, and that .serverless folder has a whole bunch of JSON files in it that define the infrastructure that you created, basically. So what we do, because if you were to run that build process using the serverless command multiple times, it will create new infrastructure for some things. So you don't want to do that. You want to actually retain that .serverless folder when you do your different deployments, so that you're not basically recreating infrastructure you've already got. That's what the state bucket's for. So essentially it's a bucket on S3 that is really just to do with the deployment process, and it helps by letting serverless know, that there's a whole bunch of infrastructures that have already been created, so it doesn't need to create everything all over again. Now, you do sometimes want to force serverless to create everything all over again, and if you want to do that, I'll show you how we do that later on. But most of the time, you're going to want to just reuse stuff you have, because you're just updating. So there's a deployment policy which has a horrible number of things in it that it requires in order to do its thing. This is straight out of the docs for this particular component. And right, and so we've set up all our stuff, our variables that we need, or our values that we need. We've got our state bucket created, we've got our secret ARN, we've got a policy defined. So now we are going to define the project, the pipeline project. So this is the pipeline project defined here. So you can see I've just given it a name. You can see I'm passing an environment variable, the state bucket. So remember, the state bucket is the thing that the serverless command is going to use to store information about what it's created. So we pass that in as an environment variable so that it's available when that build process happens. There's a cache bucket. So that's just created so that when the build is happening, code build will use that bucket to write artifacts to. Reusable things that it can cache. And this last one here is just showing which build image I want to use. Interestingly, when I didn't specify a build image, it was taking like 3 to 4 minutes every single time it was doing a build to provision the instance for the build. So when I specified that, that dropped down to 15-20 seconds instead. So, maybe that's something you've encountered in CDK or in code build projects yourself. Anyway, so you can see I've created a source output artifact and a build output artifact here. Then I've created the actual pipeline itself. So you can see there I've got my stages. So there's my source stage. So you can see it's a GitHub source action. It uses the OAuth token that we created here, and so I'm just using Secrets Manager to fetch it using the ARN, and within the secret, the key that holds the value, points to the value, is called token. These are the things we set earlier up. So the owner, the repo name, the repo branch. It's using a GitHub trigger webhook trigger. So when I do a commit to that repo, it will trigger this pipeline. And then you can see the build stage. So the build stage is very straightforward. It's basically just, it'll just basically run using the build spec, which is in the project, which is in the app project. So what it brings in the source stage contains the build spec, and it'll run the build using that build spec. We'll see that in a sec anyway. So where is it? So the build stage, or the pipeline project itself, gets this role added to it, which is the serverless deployment policy, which is the thing that allows serverless to actually run and do all the things like create lambdas, create all the things it needs. And then I'm just outputting some things, the pipeline ARN, pipeline name stuff. Okay, so that's basically the project, the CDK project, to create all this stuff. There's a README file here, which we can have a look at. So essentially, you can see here I've just talked through what needs to be in the build spec, what it's expecting to see in the build spec, and also what the various bits and pieces that need to be in the Next.js repo look like. And then it walks you through the order in which things need to be created, and a basic how do you do CDK stuff here, which is just the standard stuff about, activating the env, etc. So that's the CDK project. I've obviously already run it. I'm not going to run it here unless there's heaps of time to do it, but I don't think there will be. I'll just walk you through the serverless app now. So the key thing to see here, so I'll just shrink that down and close that. So this is just a standard Next.js app, and if you want to see it in action, it'll just run locally. So you just run yarn dev and it'll run it locally. So this is the app running locally, so it just runs it locally on localhost. I'm sure most of you, if you've done web dev these days, you'll know what that's like. And it's just a simple 2 pages. It comes with a landing page, and then it's got a search page. And I'll show you how that works in a sec. So that's it running locally. And essentially it's a very standard Next.js application. So you can, it's got a bootstrapping process for creating a outline Next.js app. So if you're interested in following along with this, you can do your own thing, or you can fork my project that produces this and play around with it. So there's basically 2 files you need to know about here. So one is the build spec. So that's the file that is going to be run by CodeBuild, or it's going to be used by CodeBuild to figure out what it needs to do to build your app. And you can see that on screen here. So essentially all we're doing here is we're creating a couple of environment variables by pulling them in from Secrets Manager. So we're pulling in the static Next.js bucket and the pre-created CloudFront ID. You'll remember that we created those in the global, in the US East 1 region. They were created in the global secret stack. The reason that we need to put them in Secrets Manager is because we're accessing them from the Sydney region, and you can't access secrets from the US East 1 region from the Sydney region. So, and then we've got some build phases. So there's an install phase. So we're running this under Node.js 12. We're doing an install. So there's a package.json file that's going to tell it what to install, and we're installing serverless. Then we're doing a couple of commands to modify the values in the serverless.yaml file, so that when we run the serverless process and do the deployment of the Next.js app, it's going to have the right values in it. So we're putting the Next.js bucket and the CloudFront ID in there. Then we're just printing it out for debugging purposes. Then we're syncing the state from the previous install. So serverless is the command that we're running to do the actual install of the Next.js app and the creation of all the infrastructure that it needs, lambdas and such. So we're syncing the state from the state bucket into the local build directory, running the serverless command, and then syncing it back out to the S3 state bucket again. So if you want to do it basically a clean build, you can just comment out the first sync from the state bucket, and then you'll just push out the new state into the bucket. So that's the build spec. And in the serverless YAML file, basically this is the serverless component that will create all the infrastructure. So this is doing all the heavy lifting. Most of what I'm doing is just coordinating this thing, doing its thing, and putting the pipeline around it, and the build process and so forth. And building the infrastructure. You can see here's the bucket that's pulling it from the environment variables, and the distribution IDs coming from the environment variables. And then we're also just naming the Lambda functions that it's going to create. So the reason to name them is because if you don't specify a name, it just creates random names every time, and it'll because you don't want to recreate these lambdas every time you do a deployment, if you name them, it won't recreate them every time. So that makes sense, I think, to me anyway. So that's all you need to do in the Next.js app. Now, obviously, what we're going to do is we've done a push out to the repository. That's going to trigger the code build process. So I'll just show you what happens when we trigger the code build process. So you can see we're doing a build here. Provisioning only took 24 seconds, which was good. Have a look at the build logs. You can see it's going to the install phase, and it's going to do a bunch of npm install type stuff. Right, okay, serverless framework successfully installed, beauty. So now it's going to do its thing here. It's doing its sed stuff to put the variables in place in the serverless.yaml file. Now it's doing its creation of all of its config files, and now it sits there and does a deploy. That takes probably about 2 minutes. So I'll just pause so you can see the build phase. So everything's pretty quick, so it doesn't take too long to do a cycle. If you're actually working on the app and you want to add new pages or modify things, to do a deployment, it doesn't take too long. The nice thing is, anyway, you have your local dev environment, so you just work on that until you've got it as you want it, and then the actual build process to deploy it out to AWS doesn't take very long at all. So you can see there we're done. 95 seconds for the build process, so that's not too bad. I said a couple of minutes, so it wasn't as bad as that. So you can see it's succeeded, which is awesome. Now we can have a look at, so there's our local host. I've got a URL for this, so next.whitesquare.com. So this is it running live. So this is the version we just deployed. So this first page is just a static page. So all it does is embeds this video, and which you can obviously listen to, and you should. And this page here, which is the search for video, is the server-side rendered page. So what the server-side rendering page does differently is that in it, so this thing called server-side props, so that's the function that tells Next that you want to render this page on the server before you send it out to the browser. So typically what use cases you'd have would be you want to use a headless CMS, for instance, to create content, and then you want to dynamically pull those content items in using IDs, like post IDs or something like that. I've just done a very simple thing for the purposes of this demo. I've got an API which I'm calling, which I'm going to send it some search terms, and it's going to send me back a video. So the reason to do that as a server-side rendered page is, well, I want to be able to manage my video catalog independently of the app. So if I've got a separate data source that stores all my videos and has video metadata and such, I want to be able to modify that independently of the app. So anyway, essentially what happens now is, that I can now put a query term in here. So if someone knows the name of a song, or part of the name of the song, or they can kind of remember a bit of the song, they can put a search term in here. So So I've got a song called Scary Grandma, right? So they might know it's called Scary something rather, something to do with grandmas, right? So they can put in Scary and they'll get Scary Grandma. Or they can put in Granny and they'll get Scary Grandma. So I can, it's just a simple example, but and I'm not going to rewrite the search engines. I know Google's moving out of Australia sometime soon. I'm not offering to compete with them, but it's just a simple example, I guess, of a page that's doing a API call in the back end before it actually renders your page. And that's about it. So I'll put the code for all this in a couple. There's 2 repositories. They're both things I'll make public and share in the notes below. Look forward to your questions or comments, and let me know if you manage to use this stuff to do something useful or fun. Thanks.
What the? Oh, my camera's turned off. Shows how well prepared I was for that. All right, so thank you very much, Guy. We're going to skip the questions for Guy. Just in the interest of time, we're already 15 minutes behind schedule. So let's wrap it up for the month. So our next event will be the 101st meetup, Melbourne AWS user group meetup on the 24th of February. So the last Wednesday of February, as always. We'll be virtual again next month, but from March onwards, we'll start evaluating how the world is traveling and when we might be able to get back into a venue. I'd like to thank our sponsors again for joining us for another year. So that's our gold sponsor, Enabler, and our silver sponsors, AC3, CMD, and Do It International. And that's it for the night. We normally have a post-meetup Zoom drinks, which is on right now. I'll paste the link in Slack in just a moment. But otherwise, we will see you all next month. Look out for the podcast. I think the recording from last month has dropped today. It's available today. We'll be recording this month's podcast on Friday and then should be out next week. We'll see you again in February.